And thank you for the warm welcome. So yeah, I am going to talk about a trend that I wrote about a year ago maybe, and this trend continued to gain steam, and I thought it would be interesting to talk to you about it. I will be talking about it in the context of ClickHouse, but it's a broader trend in open source and open standards. So with that, let me kind of do a deeper introduction of myself. I am head of product at a company called ClickHouse, which is the parent company behind an open source project called ClickHouse, which I will talk about. It's an open source analytical database. Previously, I spent 7 years at Elastic, the company behind Elasticsearch. I was there from very early days as I grew, and I was responsible for the logging, analytics, and observability use case. So I've now been in open source in a data space for quite a while. I don't want to date myself. I love this space. We were discussing at the speaker dinner the other day that data is the lifeblood, not only of organizations and decision making, but at this point technology with AI, ML. Data is what drives really innovation. So you're in the right space, not only today, but in terms of your careers, I believe. So in terms of my agenda for today, I was thinking of, first of all, to introduce this blog I wrote and kind of walk you through my thesis. And then talk about the two building blocks that I described. They're data lakes and analytical databases, in particular open source analytical databases, and how they can be combined to experiment with new data architectures and data platforms. And then I'll close with a few examples. Hopefully, if you want to get started hands-on with ClickHouse and related technologies, you'll have a chance to do that. So, my view on history of data warehousing. As I mentioned, this blog is maybe not quite a year ago, but 10 months ago. I was frankly a little bit worried when I published it. It had an ambitious title, Unbundling of the Cloud Data Warehouse. And we know the cloud data warehouse is quite prominent. In fact, who here uses something like Snowflake or BigQuery or Redshift? Quite a few hands go up, yeah. And I'll talk in a minute about why it's such an important building block for data teams. But already a year ago, and at that point, I've been with ClickHouse for about a year and a half. I saw this trend toward less monolithic systems. So what did I really describe in this blog? First of all, the trend, of course, started with data warehousing, period. What is data warehousing? It is centralized systems to house data for business decision making. And in a self-managed on-prem world, of course, there's IBM, Oracle, Teradata, commercial vendors that made this a reality. And honestly, businesses that didn't adopt such systems stayed behind. They simply didn't have ability to iterate quickly on data-driven decision-making. Eventually, Hadoop evolved as an open source alternative, but it all stayed on-prem. And in fact, with the trend toward cloud, this was one of the last workloads to shift into the cloud. And why is that? Well, it is business critical, right? It's not something you would take lightly. And in fact, I credit technologies and vendors like Redshift and BigQuery and Snowflake for pulling over finally these workloads into the cloud. Because what happened next was that it opened up these very important workloads for additional experimentations. Now, not only sort of well-trained business analysts, but broader teams, including developers, could simply access this data through a very simple SQL interface with a much broader array of tools available in public cloud providers. And the new wave of innovation started with building data-driven applications, now often for customers, right? Externally facing audiences, not only internal. And so, again, I think that was a pretty important milestone in terms of kind of data warehousing. I like to say that it democratized big data to additional workloads. But it wasn't without challenges. And in fact, if you look at the kinds of applications many of these developers wanted to build, they wanted to build much more interactive and immersive experiences, what I call real-time analytical applications. So I'll give you an example. This is actually a public demo that we provide called ClickPy. It is Python download analytics. If you have a favorite package like I do with CHDB, you can go and you can see kind of like how it's trending over time. You can filter. This kind of dashboard is the type of experience that you might want to build with data, and not necessarily small amounts of data, huge amounts of data, and you expect it to be just at your fingertips, very, very quickly interactive. Those are the kinds of workloads many developers wanted to build with the data. But if you think about data warehousing, that's not what data warehouses were built for, right? They were built originally for reports. often complex business reports. They wouldn't necessarily need to run so quickly for each query. It was assumed that if you run a report, it can take some time, minutes, maybe even hours for a complex report. And so what happened was these data warehouses were there, they made the data accessible, but not necessarily a good place for all types of applications. And real-time analytical applications would be just one example of an app for which maybe they were not fully optimized for, not designed or architected for. They were maybe a little bit slower in terms of query time. Or if you tried to speed it up, it was quite expensive because it needed a lot of compute. And so there was this feeling of lock-in. A lot of engineers I would talk to would say, I like my data warehouse, but I sometimes feel like it's sort of this monolith and I can't necessarily build everything I want. The product teams can't move fast enough. So where are we in the present? A lot of folks have recognized this trend and conversations are happening. At the same time, this question of, well, do we need to couple storage and compute in a single warehouse? Can we decouple that, right? Can we have a more open data lake concept where we all agree on a storage layer and multiple sort of query engines and application environments access this data? And that's exactly where we are right now. The industry is headed toward a much more open paradigm where you have this idea of shared storage. And most, I think, databases and data warehouses now separate storage and compute. But what's more is that we're all trying to agree on how multiple sort of applications, audiences can access this data. Data scientists, developers, business analysts, and more. So that's what I want to talk about. Really, the two concepts here are open data lakes and open data lake formats. And from the perspective of applications that I build, it's specifically open source analytical databases. But as I mentioned, there are many other applications you might combine with this open data lake format. So again, moving to this next topic, I would assume a lot of folks in this audience already know what data lakes are, but I'll just review it just for the sake of maybe anybody who's newer to the subject or even the recording. By the way, I know that these events, while they're held here locally, are broadcast to a much wider audience. This community is quite incredible. I've previously watched content from these events, and it's amazing. And I'll talk later about some of the favorite talks that I'm going to watch later today on the agenda. But back to my talk, right? So what are data lakes? Well, if you look at a typical data stack in a bigger organization, as I mentioned, there's this feeling of being a little bit locked in. You may have a vertically integrated data warehouse, or several, if you've gone through an acquisition and have a few things to deal with. You may have a data lake, or several, because the truth is we haven't agreed on a format, and so there are several things maybe that are competing inside your organization for how to organize your data lake. There's various streaming tools, the various ETL and ELT tools. Why? Because now you have to move data around, right? It's not just sort of sitting there accessible to anyone. It's kind of a mess, right? There's a lot of complexity. Sometimes, teams feel like all they do is just kind of shuffle data around and not necessarily building new things. I'm not even talking about the fact that for DevOps engineering, often there's a whole separate big data stack with another vendor, right? It's a separate story all on its own. So a data lake, at least in theory, the concept and the architecture tries to solve that by saying, well, at least the storage layer can be unified. So we don't have to copy the data. We don't have to necessarily move it around all the time. If we could all agree that data lives in an object storage and we agree on a format, in theory, all these query engines, all these applications can connect to shared storage. This is in theory. In practice, agreeing on anything in an open ecosystem is a little bit hard, right? You have to agree on a table format, how you manage these tables, and most importantly, the catalog. How do you basically list all the assets? And currently what's happening right now, as many of you probably know, is there's this kind of war of formats. Is it Iceberg? Is it Delta Lake? Is it something more unified? Whose catalog am I going to use? Is it AWS Glue? Is it something else? I do think we will resolve it as an industry. And the good news is that you as an organization can make a choice, right? Even though there's not broad agreement yet, you as an organization can say, you know what, we're going to commit to Iceberg and we're going to commit to this catalog. We're going to move forward past this complexity I showed in the previous slide. So I believe that's really exciting, and I think this is really what the industry needs to simplify the complexity. If you ask ChatGPT, what is the winning format, it gets actually very confused. It doesn't know the difference between data lake formats and file formats. The thing I will kind of leave you with is, if you're not yet haven't had a chance to dive deep into this matter, is there's file formats like Parquet, Avro, many others. Data lake formats are kind of on top of it, managing it. The two that are kind of like most important right now are Iceberg and Delta Lake. in theory, Databricks is working on unifying them. Let's see what happens. I'm actually really curious for folks in the room, who here is already either using Iceberg or planning to use it, or, okay, a few hands. What about Delta Lake? Interesting, more hands. Same as in Melbourne. So more hands went up when I asked about Delta Lake than Iceberg. Interestingly, the trend is reversed in the United States for me. That's why I always ask the audience. Some of it may be specific on what kind of solutions you already use in-house, but it's very interesting for me, geographical differences. Okay, moving on from data lakes to analytical databases. And as I mentioned, these are important in the context of a specific use case, interactive data-driven applications, but I see more and more teams betting on this as one of the key things in their product portfolio. You may be building a product for the market and you have a bunch of events and you want to expose them to your users as a dashboard or as some sort of interactive product. So in this use case in particular, both data warehouses and data lakes are not the best technical solution. So how can you combine other technologies with the concept of a data lake to make this work? And the good news is that there are many open source databases that you can adopt for this use case. And in fact, they are all moving quickly to support data lakes. So that's the good news. If you ask again ChatGPT, here it's a little bit less confused. Open source analytical databases are optimized for fast querying and analysis of large data sets, often using columnar storage. Correct, I would add here, not only is it columnar storage, it's also about vectorized query execution. These databases go into many, many directions to run queries on both recent and historical data very, very fast. Why is columnar important? Oftentimes, these types of queries in a dashboard are about taking a few columns and filtering or aggregating them. So you can't necessarily put this data in a transactional database. It's not going to be efficient. And then for data warehouses, as I mentioned, they primarily focus on complex joins, less so on kind of these queries on flat tables. I was tickled when ChatGPT said that the best and fastest example is ClickHouse. We believe so, obviously, and I'll show you in a few minutes some benchmarks. We've been doing this for a while, so I'll talk in a minute about the history of our project. But as I mentioned, it's a broader trend. And again, the comparison to legacy and cloud data warehouses are, I would agree kind of with how it described it. They were just built for a different use case. They're great tools, but for a different use case. So ClickHouse, where did it come from? It's an open source project. It's actually one of the fastest growing projects. It's been open source since 2016. In fact, when I was at Elastic, even in 2017, where it was a fairly fresh project, already some of my big customers for analytics were moving to ClickHouse, and I'll talk in a minute about why that was. But in terms of its speed of growth, it's even outpacing Elastic in terms of kind of how fast it's growing compared to when it was open sourced, and that trend is only accelerating. It is a column-oriented, distributed, OLAP or analytical database. It was built originally for a real-time analytical use case at the internet scale, which I'll describe in a minute. Even though it's been open sourced in 2016, it was in development since 2009. So it's taken 7 years to get the project to a point where it was mature enough to go into the public kind of open source market. That's what it takes to build a robust database that can run at a huge scale. In terms of the use cases, I'm just going to show you one user. I'm actually headed to Singapore next. We're going to be meeting with customers there. Ahrefs, if you ever use them, they're a tool for product and marketing professionals that basically crawls the internet at scale and is summarizing all the information about keywords. Like if I wanted to research which keywords I should create SEO content for, this tool would let me know. It's storing huge amounts of data. ClickHouse is its main data store. And the reason is, again, this is append mostly data, it's events, and you want to do fast queries. Again, I'm not going to wait for an answer for an hour, right? If I go to a dashboard, it needs to be quick. Only really ClickHouse can handle this workload. And other examples would include Cloudflare, similar use case, again, internet scale analytics, user-facing analytics. But not only, right? Very quickly, internal teams have discovered that these databases can also help them serve internal stakeholders who are also much less patient than 5 or 10 years ago. They still expect very fast performance to internal interactive dashboards. So we see Advinta moving over from BigQuery because it was, again, less performant for this use case, and so on. Two other use cases are data science and observability. This is where we have less kind of a solution, but it's more like a building block. So if you're an observability team building your own stack, maybe you have Grafana, you could use ClickHouse for structured data, logging or traces. And finally, in data science, there are two big use cases. One is feature store. So as part of your training, maybe producing tons of features, like where do you put that? A structure store for that using ClickHouse or similar technology is very, very efficient. And then finally, for vector search, which is going to be more and more prominent going into the future, combining with regular aggregation-based analytics. All right, so one thing I just wanted to kind of show as an illustrative point. Again, why ClickHouse? Why couldn't I just use an existing data warehouse? Again, the right tool for the right purpose. I just wanted to demonstrate the difference. So what we did is we took this application that I showed you, ClickBuy, and we actually built it on top of Snowflake. We're like, why not? And we have some solution architects that came from Snowflake. We're like, we're going to do our best to optimize Snowflake on top of this use case. We keep hearing from customers that when they migrate from Snowflake, they have all these benefits, but let's see if we can kind of show it in numbers. So we wrote a blog. You can actually read it at this URL. And indeed, we actually optimized Snowflake to the point where it was not 10x, but only 3 to 5x more expensive than ClickHouse. But we still couldn't reach the level of data compression and speed for queries using Snowflake. So again, what is the reason for that? I'll give you just a few technical details. And again, if you want to go and dig into the blog, you can see. In order to make a real-time analytical workload fast, you have to actually sort it. Not only do you need to put the data in columns, you have to sort it just the right way for access to be very precise. When you do a range query, you need to pull out just the part of the column that's needed. So in Snowflake, this is called clustering based on primary key. Without that, you see the really big column. That's the very slow response. Without clustering, with clustering, it gets better, still not as fast as ClickHouse. But unfortunately, the issue was that this feature was actually very compute intensive to run in Snowflake. So it just really ballooned your bill. So could you do it? Yes. Do you want to? Not really. It's just not efficient. Same with data compression. Sure, we turned on a few tricks in Snowflake, but in the end, ClickHouse had many more optimized data types to get the schema just right so that your data stays very, very compressed and uncompresses very quickly during a query. Just could not get there with Snowflake. Again, just wasn't a focus for whoever was building the product. It wasn't optimized for this use case. So in the end, it just came down to cost being untenable for this use case. Again, I wouldn't compete with Snowflake in the data warehouse sort of long reports, but for real-time analytics, ClickHouse was purpose-built, Snowflake wasn't, right? So in the end, I believe kind of where we are right now is we should move to data lakes because this allows open access to many applications for any data. And I believe at least for real-time analytical use case, open technologies like ClickHouse allow you, in combination with data lakes, will allow you to build those interactive data-driven applications. Now, what's required to make this architecture work? So first of all, the first question should be, do you even actually need a database like ClickHouse? I'm open to the fact that in some cases, a data lake may be important. Data lake plus Trino by something else, if it's fast enough, great, use it. But it's not going to be fast enough in all situations. When you need very fast streaming sort of data coming into a database, again, a real-time analytical database will outperform the current data lake technologies right now. And more importantly, the interactive queries will still be faster in a technology like ClickHouse. So I'll just kind of show you some examples. On the speed of writes, in something like an object store, there's no trick really. The object stores have great throughput, but you need to resource the workers that are doing the writes appropriately. You have to parallelize the write. And as you see from this curve, at some point, the number of writers that you add, they help kind of the curve of slashing the latency and the throughput of the writes. But with each incremental step, it gets less and less efficient. So at some point, if you have a common platform, you might stop and say, okay, this is enough. But if you really want to optimize it for a particular application, you may go further. So that is the challenge. And again, you may need to optimize your writes for a specific application with a different number of writers. Within ClickHouse, and again, you can look at this blog, we were able to get the speed of writes to be really, really optimized using not only a lot of workers, but also some additional settings that data lakes don't have. So again, for streaming writes, you may need to write directly to an analytical database. But as I mentioned, more importantly for reads, and I mentioned this before, this is the benchmarking site called ClickBench. It's public. You can go there and you can take a look at various cuts of data. This is, while it's maintained and kind of governed by ClickHouse, we have open source communities submitting benchmarks to this place, and you can see that queries from data lake versus a real-time analytical database for this use case, are much, much slower. Over time, could they be optimized? Possibly, but this will require for the formats like Iceberg and Delta Lake to significantly evolve the storage format and the access format, which could happen over time, but right now the difference is stark. So what we're seeing users do right now, first of all, many, like you, are moving to the concept of an open data lake. Iceberg or Delta Lake, again, kind of varies by geography, interestingly. For real-time analytical applications, they're combining a real-time analytical database, but their requirement is that it works seamlessly with a data lake. And I'll describe in a minute what that means. So first of all, there's two use cases. One is where streaming ingest is very important. And then you do a double write. You write into the data lake as your source of truth, and then you write into real-time analytical database using the fast path. You may TTL out the data in the real-time analytical database if you only need recent queries to be fast. And in fact, the best analytical databases will be able to query not only local storage optimized for fast access, but also the data lake for hybrid queries. That's what ClickHouse does. One other trick that I've seen really help is creating materialized views on top of the data lake inside the real-time analytical database. So even access to that data gets much faster. Finally, optionally, you can write data summaries to the data lake so that other systems can benefit from faster queries, basically taking your materialized views and maybe materializing them into the data lake. So that's one example. The other example, actually, is if your data latency is not that important, if you can wait some time for the freshness of the data, you don't need to do the double write. You write into the data lake, and you have the real-time analytical database grab that data and sync it in periodically. Again, this does not guarantee freshness, but you can get the data in on a regular basis, and everything else looks the same. You can do the queries both locally and remotely. So those two architectures work quite well and allow you to combine the best of both worlds, keeping data lake as your source of truth, but combining it with the best of an open source real-time analytical database. So hopefully that's clear. In terms of time, I think I still have a little bit of time. I'm going to go through a couple of usage examples just in terms of how to get started with something like ClickHouse. As I mentioned, it's open source. You can just download it. You can set it up locally. I'm going to use a tutorial that's available in public. On our website, there's a single command to download this binary. It's just one single binary, no dependencies. And there's a lot more demos and like a public playground you can go to. Finally, we have a cloud offering for those that prefer to get started in cloud. So in terms of ClickHouse technology, there's three sort of modes in which it can run. It can run locally on your laptop as like a server. You can use it as a client. And actually, sometimes it's a very effective ETL tool to like connect to, say, Parquet files in your object store, transform them, write them somewhere else. We call it ClickHouse Local, where kind of the data store is embedded. And finally, there's an in-process version of it, for instance, in Python, if somebody likes to do analytics embedded into their actual sort of Python application. So all three are available. I'll just show the first one here. All you do, as I mentioned, is just you grab this command, you put it into your favorite command line tool, and that's it. Like the download is very fast, and at that point you just run the binary. There's no Java, there's no dependencies. You have ClickHouse after just running that command, and you can use it in either mode. In cloud, again, it's self-explanatory. I'm sure you've used thousands of cloud services. We run in all major cloud providers. We have kind of access points across the globe. And there's a few more security steps, obviously, to protect your endpoint. But after that, you connect to the database in exactly the same way. There's a connect dialog, and you can just simply access it after it's provisioned in a minute or two. The next question becomes, OK, so how do I learn this technology? It is SQL. It's pretty close to the ANSI SQL standard. There are a few extensions, so there are some functions that kind of extend the SQL standard to be even more compact for analytical queries, but SQL should just work. What I usually recommend is if you have data sitting in your data lake, just first try to query it directly. Don't try to load it yet. Try to query it directly. We support all kinds of file formats. We support, as I mentioned, data lake formats as well. So that would be my recommendation. I think that's the first example I have here. Basically running a federated query. Again, going back to this environmental sensors, there's a query right there. The format of these files is actually just CSV, so it's very inefficient. So I would expect this query to take some time to run. Something like Parquet would have been faster. I think this one takes 12 seconds, as I mentioned. But this will be kind of a good baseline as we start to see, okay, like what do we do with this query? How can we optimize it? One way to optimize it, instead of using local resources on my laptop, is actually connect to a cloud instance and see if more compute helps. And as you'll see in a minute, I actually spun up a pretty beefy node. More compute doesn't help that much. So I'm going to run a query, and it's going to take, instead of 12 seconds, 6 seconds. Well, that's not great. I think I like 10x the resources. The reason for that is because the file format is not optimized. Again, CSVs, everybody knows, messy file format, not great for large-scale querying. No big surprise, really. So let's just say, again, like you did this query against the data lake, it's not fast. You're like, I really want to run interactive queries. What can I do? How can I compare? What happens if I load data into ClickHouse format? Pretty easy. The easiest way is actually just to use, again, command line, insert select statement. Very, very easy. So I'm going to show you that as an example. There's others. In the tutorial itself, there's a create table statement and an insert select statement. So that's what I did here. I created a table, and I'm running insert select. And again, this is like, I think, a terabyte sized file. So you see it's going to take some time to load, and the command line client shows you how many rows per second it's loading and how fast, basically, it's proceeding. Once you load the data, you can see the queries. But before that, I also wanted to show you, if you're in the cloud, you have a lot more tools, obviously. The cloud service is going to be kind of an extension of open source with additional sort of UIs. The nice thing about this one is if you don't know the schema that you want to put it into, if you're not following a tutorial with like a nicely created schema, you may want to explore your files. You may want to say, like, what's my table structure? So the cloud offering is going to be a little bit more educational in that sense. It'll let you kind of like go through a wizard and kind of learn. But again, it's all based on open source. Anything you do in cloud will be compatible with how like open source works. So think of it also as a training ground. Probably not going to play this whole video. So querying the data, once you load it inside ClickHouse, again, hopefully this is quite fast, right? And so I'm going to copy that same statement. I'm going to use the UI client in cloud. And I'm now querying the local table. And indeed, like this is a fraction of a second, 10 milliseconds, in fact. That's what you expect from interactive queries, right? Like that's the difference. Sometimes users tell me that when they run a query in ClickHouse, they think it's broken. They're like, it's so fast, it's broken, obviously, right? That's what I love to hear, right? Even an inefficient query as this one, I didn't create an index, took only 4 seconds, right? So basically, that's the goal. The goal is to get your queries to seem like they're broken. And again, the UI in cloud has a lot more capabilities. You can chart data, you can kind of see. We even have a feature where you can take a query and publish it as an API. If you have a team who wants to iterate on kind of a data product, it's a very fast workflow. Finally, of course, we must have an AI feature to help you create queries, right? Must. What I've noticed that it actually does quite well to give you the right query. It's not always the most optimized because it doesn't know what indexes you have. So we'll give you the right syntax. It'll help you learn the product. But you may still need to go and iterate on query optimization using a separate tool set that we have. But yeah, I mean, AI is amazing. I, by the way, use it just as a way to speed up my query writing. I don't love typing in SQL manually, so it's a great way to kind of learn. All right, summary and next steps. Just wanted to bring it home. So data warehouses, amazing technology. Took what we had on-premise, brought it into the cloud, opened it up to a much broader set of use cases, including real-time analytics. Turnkey solution, vertically integrated, definitely the right bet for data warehousing in the cloud. The cons are lock-in and cost. But lock-in is also changing. I mean, Snowflake users, you know that Snowflake now fully supports Iceberg. So it's clear that data warehousing industry is shifting to data lakes, That's clear. Open data access, it's built on object storage, supports many formats. The issue is it's still evolving. Actually, right before coming here, I met with the Tabular team, now part of Databricks. They have a vision of a unified data format and unified standard. I really hope it happens. They seem committed to it, right? But in the end, your organization can make a choice today, be that Delta Lake, be that Iceberg, and just start moving forward. And finally, for certain types of workloads, like real-time analytics, you will need to consider specialized technologies. But the important part, I believe, is that they work seamlessly with data lakes, which is clearly where the data industry is headed. So that's the bottom line. And then in terms of when you think about kind of your cloud data warehouse, and like maybe unbundling is not the right word, but figuring out how to move toward this vision of unified data platform, what I usually recommend customers is look at your workloads, try to identify which ones are customer facing. And one of the tricks that I've seen actually is look at workloads that compared to their storage, their compute is quite big. Usually it means that there's a lot more concurrent queries accessing this workload and iterating fast on it. Often that's a good candidate for optimization, for basically figuring out if you want to use a different technology for it. And then iterate. Just look at different workloads and see which ones make sense for you to optimize. So that's my practical advice. If you would like to see more details, as I mentioned, there's a blog out there that I wrote a while back. And if you want to connect with me, I'm available on all sorts of social media. All right, so I think we have 5 minutes for questions. Okay, perfect. Thank you so much for being a wonderful audience. And I'm happy to take questions.